I'm going to show you a demonstration today that will astonish you. This is a rotary flux generator system right here, from here over to here. And I typically use it with my 24 volt solar. I've got one solar panel, and then it uses this system here, and it charges up 4 high performance batteries and 4 other deep cycle batteries. It all runs through the MPPT as remote controls, and then comes out of this inverter and plugs in and runs my equipment. All right, so this thing runs at 230 volts at 19 amps AC, or it runs 460 volts at 9.5 amps. Either way, it's 4,370 volt amps reactive, which is VAR, which is going to be a little bit higher than the actual watts. So let's just call the actual watts, which we'll read watts on this watt meter here, at 4,000 watts. Okay, so 4,000 watts. Wow, that's a lot. And this 1,770 RPM. This is the rotor here. I call this system a RotaFlux. Like I said, it's a rotary flux generator, and I'll explain why. These are rotary flux toroids here, and like I said, this spins at 1,770 RPM. It's got N52 magnets here, north south, and then it's got dual coils on each. Each one produces 26 volts, and this is 26 volts, and I've got them connected in parallel, so it boosts the current up and still keep the 26 volts for the 24 volt system that's down here. We're not going to use this stuff down here at all. It's totally disconnected, so this is totally independent right now, this and this and this. All right, so the other power that comes off this is kind of amazing too, is right here, these two little wires. I don't have them hooked up to the bridge rectifiers, but they go back here in this, and then they go into the control panel box, and here there's a bridge rectifier in here, and it takes the third phase of this and turns it into a rotary transformer, and it gets rectified inside here. It comes out in the form of DC to here at 40 volts. So what I normally do is I just take that 40 volts with a 26, put them all together in parallel, and then just throw them into the MPPT and let it sort it out and power the system. So that's what it is. Now, I only have one solar panel. It's like a 300 watt panel. So it's like, wow, what are you going to do with 4,000 watt motor? Holy cow! How are you gonna where's the advantage to that? I know it doesn't sound crazy, but what I'm going to show you that's going to astonish you, that this whole thing is that's going to run this giant motor. It's going to make these into generators and produce the power here. And it's going to run this Variac, and it's all going to be running on this one little cap module. Now this is the amazing part, because how in the world can this run all of this and generate electricity at the same time? How can it do it? Well, it's really simple. This isn't running on 4,000 watts. This is going to be running on 30 watts. I've got it rewired, and I've got it fine-tuned with, I must have went through it, I don't know, 10 or 15 different AC capacitors to tune this thing. But usually starts up at about 31, 32 watts, which you'll see on the meter shortly here. And then after about 20 minutes or so, it'll drop down to like 28 or 29 watts and still run all of this. So what I'm going to show you is down here, this cord is my mains power cord. And this is the cord here that goes to the Variac. It's going to plug into the mains, and it's going to start this. Now, why do I have to do that? Because over here, the inverter is, as you can see, it's only a 300 watt inverter. It's pure sine wave, because you need that for when it hits the resonance in this motor, which is interesting, and you'll hear that too, and you'll see it on the little light on here. It gets real bright, and then you hit the switch, and when it goes into resonance, you hit the switch, and then it drops everything down, the power consumption and everything. But this is 300 watts, and this usually requires, to start this system, about 450 watts. So because it's just a tiny little inverter, but that was part of the demonstration. I wanted this side right here, excuse me, this little graphene cap module that we sell. We've been selling these for over a year now, and I've sold hundreds of these. Usually somebody will buy one, they'll come back and they'll buy more, because you can build a whole system with these things. And I've explained 100 times that these things will start a 4-cylinder engine, automotive engine, combustion engine, 4-cylinder, 6-cylinder, and even an 8-cylinder engine. These are super, super powerful. That's how it can run this whole system and do its thing. And I'm going to prove that to you and show you. So I'll go ahead and like I said, I'll plug this in to the mains. I'll plug this into the mains, and it only takes a few seconds for this to start up, and then it makes this loud sound and the light gets real bright. You hit the switch, it's in resonance. So then I'll unplug this and I'll plug the variac here into the inverter here, the little 300-watt inverter that's powered by this. So this little cap module is going to run this inverter, it's going to run this motor, it's going to run this variac, it's going to make electricity here and here from the third phase rotary transformer, which would typically would feed this, but that's not the demonstration today. The demonstration today is to show you how this little thing can run all of this equipment and still generate electricity. And not only that, but it doesn't just do this for like 1 minute or 2 minutes or 5 minutes. It'll do it for about an hour and 15 minutes continuously. And the only reason it stops at that point is because when this 16 volts drops down to about I think it's 11 volts or 11.5 volts, I think it's 11.5, that it automatically cuts it off. And so you're only using from 16 down to 11.5. I mean, you got a lot more energy that's still stored in this, and it still has run this system for like an hour and 15 minutes. Okay, so let me go ahead and put the camera on a tripod for a second here, and then I'll plug this in. I'll show you on the camera, and then we'll go ahead and do that and plug it into this and take it from there. Okay, just to orient you, the motor cord is right here, and it plugs into the watt meter, and the watt meter cable is right here, and it plugs into the variac over here, and this is the variac and the mains, and I'll plug these together in just a second. But what I'm going to do is I'm going to start it with 120 volts on this, which I could get out of the little inverter, but again, you know, I need 450 watts to get this started for a few seconds to hit resonance on this, then turn it off and plug into this. So what I'll do is once it starts up, I'll turn the variac down to about 60 volts, and that's the voltage it likes to run at, and you'll see where it is then going to be consuming about 31 or 32 watts, which will drop down to about 30 pretty quickly, and then even lower than that after a little bit of time. So let's go ahead and start this. So I've got this plugged in. All I have to do now is turn on the switch on the variac over here, and watch it start up. Listen to the sound that it hits before I hit the switch over. It's on the back side. This gets real bright. You can't see it. It might be off frame. There. And then I hit the switch. Now this is the volts. It's showing on the meter. Let me just zoom in on that so you can see it. Alright, so it's 124 volts that's drawing right now. So I'm going to turn the variac down to 60. Okay, that's close enough. 60.5, we're going to live with that. And this is spinning at 1770 RPM, and this is producing electricity right now. This is also producing electricity, and we've got it, this is still on, it's going to remain running. Okay, so right now, well, that's even better. Okay, so right now we're running at 29 point whatever watts. That's the actual watts that this system is demanding. And so let me put the camera back on the tripod, and we'll disconnect the mains and plug it into the little graphene cap module. Alright, oops, sorry. Okay, so let me go ahead and turn the little inverter on here, and Here again is the mains power, and I have to do this pretty quickly, so let's just go ahead and plug it right in. Don't need that anymore. Now we're running the whole entire system on this little graphene cap module, which is running this, generating electricity. And let's see, because I unplugged it, it automatically goes back to volts. So we're still at 60 volts, which is good. So let's just hit the watts, and we're at, okay, that's fine, 28 to 30 watts. So it's going to vary a little bit. And it's ready to go. It's ready to use the power from here and the power from here, connect them together, cable it down to the MPPT, and let it do its thing for the 24 volt system there. But the objective of this video is to show you how powerful these little modules are. This is what product of ours. So this is what I'm selling, is this. This is unique. I mean, this is mine uniquely, and the RotaFlux design is my own design, and so, you know, that's another product for later. But and I've got other products beyond that that I'm working on too that still utilize this, because this has a ton of energy. And that's why I'm saying it. This is a great time to get. We've got a bunch of these in stock. We've got more of them that we're getting made, having made right now. So so it's going to be a really good time to order if you want one. But I want to show you what this does, and you're seeing it right now. It's not connected to anything over here, not connected to anything back here, nothing. It's just this is running this, going over to here, running into the motor, and going through the watt meter in the process. And you're probably seeing something like this for the first time. So this is it. So anyway, well, thanks for hanging in there with me.